Okay, so this is chapter 11, question 17, bonus material. First, I'm going to go through and calculate the effect size measures for question for 17A. The effect size measures, all three of them are going to change 17A versus 17B. And I'll show you why as we go through it. So estimated Cohen's d is equal to the mean difference divided by the population difference, or what's expected in the population, divided by the standard deviation of the difference scores. So in 17A versus 17B, the standard deviation of the difference scores was different, and so Cohen's d is going to be different for these two, the two parts of the question. So I'm just doing 17A, the effect size measures, where it had a standard deviation of 4. Our t obtained was 3, and our estimated standard error was 1. We only need that standard deviation and the mean difference for our Cohen's d. So the mean difference was 3, subtract 0, divided by the standard deviation, which was 4. And so 3 divided by 4 is 0.75. That is a medium effect. It's not a large effect because a large effect is 0.8 and 0.75 is smaller than 0.8. R squared is t squared divided by t squared plus your degrees of freedom. R squared is going to be different for 17A versus 17B because our t changed. The t in 17A was 3, so we're going to have 3 squared divided by 3 squared plus the degrees of freedom, which we calculated in step 2, which was 15. So we have 9 divided by 9 plus 15. So we have 9 divided by 24. 9 divided by 24 is 0.375. This is a large effect. The cutoff for R squared between what goes into a large effect is 0.25. 0.25 is smaller than 0.375, so we've got something bigger, so we've got a large effect. And then the confidence interval. Let's do, I can just pick one. Let's do a 90% confidence interval. Okay, 90% confidence interval. To calculate the confidence interval, our formula is mu v equals md plus or minus t times the estimated standard error. The confidence interval is going to differ between 17A and 17B because the estimated standard error differs between 17A and 17B. So the mu d, or md, that mean difference was 3 plus or minus. Here we need a different t critical than this. This was for step 4. We need to go to table B2, and I'm going to explain what column we're going to be looking at. we want 90% in the middle. We want our confidence interval to be 90%. The whole area under the curve adds up to 100. So 100 minus 90 means that we've got 10% in the two tails combined together. So what we need to do is we need to take that plus our degrees of freedom and go to table B2. And I'm going to look in proportion and two tails combined, 0.10, and I'm going to go down until I get to my degrees of freedom. And here my value is 1.753. That's the number that I want from the table. So note that this T in the confidence interval is from the table, from table B2. It's not from your 4-step hypothesis testing procedure. So I have 1.753, and the estimated standard error for 17A was 1. So if and when, I'll do 17B too. I'll do all these for 17B. When I do that, the mean difference won't change. The T won't change, but the estimated standard error changes when we change the standard deviation. So our confidence interval is going to change. So we have 3 plus or minus 1.753. Not quite done yet. So if we have 3 subtract 1.753, we have 2.247. And then 3 plus 1.753, we have 4.753. Okay. So those are our values, and I'm going to pause here. I will come back and I will do these same values for 17B.